So I'm going to start with the share and the review from last week. Last week we talked about classes, but also something new that we can do called inheritance, which was kind of a way of reusing code that we've already written. For example, we already have a class that maybe does something useful, and we want to make a new class that kind of just builds on top of it. So instead of starting from scratch, we take advantage of our old code and we inherit some of the features to our new class. And so that's what all the review questions are about today. I'm not going to go in order of how they're listed on the slides, actually. I'm going to start actually with the second one, and we'll do the first one last. So based on what I just said, it kind of just sounds like we're copy pasting our old code into our new class, because essentially all we're doing is just reusing the code that we've already written. So can anyone tell me why inheritance is preferred over simply copy pasting? As a hint, this is kind of an idea that we've been talking about a lot through Java 2. This is also why we have functions instead of copy pasting code. This is why we have loops instead of just repeating commands over and over again. Why do we not like copy pasting code? Yeah. There can be multiple correct answers. It's a little bit of an open-ended question, but if anyone would like to put a message in the chat or speak up. Okay, so it's quicker and you don't need to repeat yourself. So I agree completely with that. So you might say, oh, copy paste is really fast, but you can imagine Java classes get massive, right? We've been working with really simple classes. It's all that we need for our examples in class. But if you imagine like the classes that we've been working with so far, just take the scanner class, for example. Think about all the like different complex things that the scanner class does, right? It uses so many like functions and fields and everything to make it all work. And so if you want to like extend that, if you want to, yeah, so if you want to like build on top of it, that's like a lot of code to copy paste. Maybe you miss some, maybe something goes wrong. It's just a pain. And also don't repeat yourself is kind of the main principle I was looking for. Repeating yourself in code by copy pasting is almost always a bad idea because it makes changing it really difficult later on, because you might be tempted to like, oh, I'm just going to do this really quickly, and once it works, I'm done, and I don't need to touch it anymore. But in the real world, like when you're writing code, and so if you copy paste code and you realize you need to go back and make a change, whether it's a bug, whether you want to optimize it, whether you just want to change a variable name, if you copy pasted code, you have to go and find every place that you've put it and then change it at every one of those locations. And if you miss one of them, it could potentially crash your program, which is really bad. But with functions, with loops, with inheritance, we kind of remove this problem by having built-in ways of reusing code without actually having multiple copies. It's just one copy that's shared in a lot of different places. So that was the second review question. The next one, I just want to do number 3. The answer is one word. We talked about what inheritance is, but how did we do it actually in Java? There's like one keyword that you use to tell Java, hey, I want to do inheritance. If I have a child class and I want to inherit from some parent, I say blank the parent class. What is that blank? Like class, child, blank, parent class. I see my chat has an answer. Okay, Andrew said had a problem. Okay, yeah, so sometimes that can be an issue. Sometimes it's Eclipse just being weird or your IDE. I will I didn't have the time to look at the homework ahead of time today, but I will definitely look at it when I have the time. And I think I saw your comments, so I'll respond to that in your post. Oh, okay. So if you leave that as a comment on your Google Classroom, you don't have to submit to leave a comment. I'll definitely make sure to remember to look at that. Sometimes you just have to be careful of naming, make sure it's like, it sounds really dumb, but make sure that the spelling is exactly the same, capitalization is the same. Sometimes just saving the file makes Eclipse realize it's there. It shouldn't be a position issue, but yeah, if you want to, that would work as well. So I stopped my screen share, you can take it and let me take a look at it.
So the problem is with this part, it says that the super constructor warrior is undefined. Oh yeah, and this is extension of this.
I see. Yeah. Okay. So this is something that I kind of glossed over, but if we look at the warrior, I like your comments. I really like your comments. You have a constructor there, which is great. It takes in 2 integers and does some stuff. Something I didn't really enforce a lot is that every single class, if you don't write a constructor yourself, has what's called the default constructor. And what the default constructor does is it basically takes no inputs and basically does nothing. Every class needs a constructor, so that's why it's put there if you don't have one. But in your case, you wrote a constructor. And so you have a 2-argument constructor there. Because you wrote a constructor, it doesn't put the default constructor for you, right? So when you just have a class warrior, that's perfectly fine. The problem happens when you try to extend it. So if we look at your Archer class again, if you can flip back to that tab, Java does some stuff automatically. And so when you have a constructor for the Archer class, you said class Archer extends warrior. And so that was the answer to the third question. Extends is our keyword. So this Archer class is inheriting from the warrior class. When you write a constructor in the Archer class, it automatically tries to call like the no argument constructor, the default constructor of the warrior class. It just automatically does it. And so it's trying to do that, but it can't find the default constructor because you don't have any. So one way you can solve this is if you go to the warrior class, you can create a no argument constructor. You don't really need to put anything in there. Yeah, it could just be empty. And if you save this and go, or you can put code, perfectly fine. You can have some generic defense and attack. Yeah. And if you save this file, hopefully, if you go back to Archer, yeah.
Oh yeah.
The arrow went
oh yeah.
Yeah. So it's just a little bit of a quirk. I definitely, since we don't have a lot of time, like I definitely gloss over some of the finer details, but that's one of the things you have to be careful of when you're extending classes. I think there might be another way around it, but that's like the easiest way to solve it.
Okay, thank you.
No problem. All right. Share my screen. So we answered the last 2 questions. First is don't repeat yourself. Next is you use extends is your keyword. And so the first question is kind of a more technical question as well. I'm asking you, what is being inherited from a parent class? Or like, what can you inherit? We said a class has fields and methods. So do you inherit only the fields? Do you inherit only the methods? Do you only inherit the public members, like so the public fields and the public methods? Or do you inherit everything, whether it's public or private? A little bit of a tricky question. I'm not sure if I said the answer exactly, but if you had to make a guess, if you're not sure, what do you think is the correct answer? I want a couple people to put into chat, maybe just A, B, C, or D. If you're not completely sure, perfectly fine to make a guess. And we can go over the answer after. Or if you don't feel comfortable putting an answer into the global chat, you can also private message me A, B, C, or D. So I can see it and you don't have to worry about other people. So I'd say, I think two of them are probably look more appealing. I think if I had to say, I think C and D are probably the more appealing choices. I can say it's not just the fields, it's not just the methods. So you can inherit both. You can inherit fields and methods. So the question is, do you inherit all of them or do you only inherit some of them? Like, are there some fields and methods that you aren't allowed to inherit? All right. Let me actually, let's see. Let's see if I can bring up the clips. And in case you aren't sure public versus private, for example, like these are public fields, but I can very easily make the color a private field. The constructors I have to leave public, but for example, the break method, I could also make a private method. So the question is, if a method is private, do you still inherit it? Right? We said private kind of reduces the visibility. Other people can't see your private methods, can't see your private fields. They don't have access to it. So I'll go over the answer now. The answer to the multiple choice question, go back, is D. Might be a little bit surprising, but actually you can inherit everything, and you do inherit everything. So every single field, every single method in your parent class, you get for free. Like I said before, it's essentially like just taking your old class, copying all the code in there, and pasting it into your new class. That's essentially what inheritance does. There is a little bit of a warning though. Even though you inherit private fields and private methods, you still don't have access to them. So they're there, but actually using them is a little bit tricky. You need a little bit of like extra help to actually take advantage of it. So that's why like sometimes the private stuff is a little bit weird, but it is inherited. Everything is inherited. So you should just remember that everything is inherited. Inheritance is not like discriminatory. Like it does not just say, oh, pick some to inherit, leave some out. It's you get everything. You get all or nothing. Right? So that was the review and the homework. Like last week, because it was more of an open-ended, people could do different things. I made it. I'm not gonna go over it in class. It just doesn't make sense for me to. But I will leave comments for the people who submitted, and we'll move on from that. But before getting into like the main content for this week, I want to take a little bit of a step back and kind of motivate you on like why all this is important, I guess. Because a lot of time, especially with this stuff like classes, inheritance, like it gets a little bit abstract and it's like adds some interesting theory, I guess, but like, why do I need to know this, right? Why is it useful? And so what I have on the screen here, it's just a really dumb diagram, but it outlines the 4 principles of object-oriented programming. And so this is like really important to know for the future, especially like when I've been interviewed, I've been asked, what are the 4 principles of object-oriented programming? In your classes, if you take computer science in college, they're going to talk about the 4 principles of object-oriented programming. And so it's okay if you don't like fully understand each part in depth now, but I'm just telling you, this is like a really important thing to start learning, at least if you're interested in programming, especially like Java, Python, C++, JavaScript. These are all object-oriented programming languages. So these principles apply to different languages. It's not just Java. So what are the 4 principles? Well, I think encapsulation is typically the first one. Then we have inheritance, polymorphism, and abstraction. So we've actually kind of talked about these. Obviously, inheritance should look a little bit familiar because it's what we talked about last week. We've actually covered encapsulation a little bit. And polymorphism, I think I already touched last week as well. But for this week, I really want to focus on these 3, connected what we've learned to the pillars, the principles. And next week or last class, I think I'll get to abstraction. But again, it's just like the 4 principles, they're big and they will be useful. So the slides will focus mostly on polymorphism and encapsulation. We're pretty much done with our discussion of inheritance. Recap. Yeah, it looks a little bit funny because they called it OOPS. It's OOP because of object-oriented programming. Again, it's object-oriented because everything in Java is an object. Strings are an object, arrays are objects, scanners are objects, files are objects, numbers are objects, everything is an object, right? Everything you do in Java is just manipulating objects. You create objects, you tell them to do things, you have functions that operate on objects. Everything is an object. So it's object-oriented programming. Again, inheritance is the idea of kind of building upon what you already have, reusing code. You have behavior that is useful for other classes, and so you take advantage of it. That's what inheritance is. I want to do polymorphism next because we kind of touched on it at the end of class. So it's kind of a nice connecting thing. But in general, polymorphism, if we break down what that means, if you know a little bit of Latin or Greek, poly means many, right? Like polynomial polygon has many sides. Yeah, poly just means many. And morph means form. So polymorphism literally just means many forms, literally. And so what this means in programming, at least, in Java, in Python, and anything that does polymorphism, it basically means that how something works, how something acts, can be different depending on the context. So maybe you have a function like called foobar, and in one context, foobar prints foo. In another context, it prints bar. These are just made up words, very common for programming at least. So the idea is it's like there's one thing that can act in many different ways, right? There's a couple of ways that polymorphism is achieved, and we actually saw one a long time ago. We saw something called method overloading, and this is called compile time polymorphism. And this is when a single method, or it's when a method has different signatures, but the same name. So this is when you have like, actually, I think I have a slide right here, just at the top. The plus operator is actually an overloaded method. So we don't really think of it as a method because it's kind of like a shortcut built into Python. But when you say like something plus another thing, that's actually calling a method to do that addition. And maybe you didn't realize it before, or at least realize the importance of it, but we've seen that you can add numbers together and then it does numeric addition, right? If you add 1 plus 2, it gives you 3, right? It just does math. But you can add other things, right? You can add strings together, right? And in that case, it will do string concatenation. You can add a string plus a number. And in that case, it would turn the number to a string and then do string concatenation. Right? So the idea is it's a single thing, it's a single plus sign, but it can do many different things depending on the context, depending on how you're using it. And so that's really what polymorphism just means. Like one thing that acts in many different ways. It might just be 2 different ways. It could be 10 different ways. As long as it does more than one thing, it's polymorphism. This is called compile time polymorphism because if you remember how a Java program works, you start with writing the Java code. Then you compile the code into what's called bytecode, or like something that the machine can understand. And then you run that compiled code. So there's compile time and there's runtime. This is compile time polymorphism because at the time you're compiling the code, Java knows what to do already, right? Because it looks at your code. It's like, what are you adding? Oh, you're adding 2 strings. I'm going to do concatenation. Oh, you're adding 2 numbers. I'm going to do math, like arithmetic. Right? It knows ahead of time. It knows when it's compiling the code exactly what's going to happen. So it's polymorphism, but it's resolved when your code gets compiled. But there's another type of polymorphism. There's runtime polymorphism. And that's related more to the inheritance. It's something a little bit new that we haven't seen yet, too much at least. And that's method overriding, which is, like I said, runtime polymorphism. It's related to inheritance. And the idea is the child inherits a method from the parent class, but it defines its own version of it. So even though it inherits one from the parent, it defines its own version. And now there's 2 that exist. And Java has to decide which one to use. And so sometimes it will pick the parent one, sometimes it'll pick the child one. And again, that's polymorphism because it's like, it's kind of one method. It's only one, but there's 2 different versions of it. And so you have to choose between them somehow. This is runtime polymorphism because a lot of times when the code is being run, when the code's compiled, before you run the code, Java can't figure out which one you want. There's actually ways to like confuse it so it doesn't know. And in that case, it only figures out which one it should run when you run the code. And so that's why it's runtime polymorphism. It's polymorphism that's decided when you run the program. Only then does Java know, hey, I should do version A, or hey, I should do version B. Let's look at a code example of overriding because it is a little bit new. I have this on my Eclipse already, but I can copy paste this into chat if you like. You just want to take this code and put it into a class called polymorphism with a capital P. If you want to put it into your Eclipse as well. If you want to name it something else, just change whatever this public class is called. So if you want to store this into like class7.java, just change this to class7. The class name just has to be the same as the file name. So if we took a look at this code, we should start at the top where we define our first class. We define an automobile class. Right? And all that there is in the automobile class is this honk method. And all the honk method does is it just prints out the string honk sound. Right? That's all it does. I mentioned this in review, but there is like a implicit default constructor. Even though we don't write the constructor, Java says, hey, I need a constructor for this class. So let me just put a default one, right? Takes in no arguments. It really doesn't do much at all. Then we do a little bit of inheritance. Right, so we define a new class and I called it sports car, and it extends automobile. So we're doing inheritance here. If we didn't have this, right, at this point, if all we wrote is class sports car extends automobile, this sports car class gets the honk method from the automobile class. Like it gets it for free because it inherited. But we defined our own honk method, a new honk method in the sports car class. And it's very similar. It just prints out a different string. It says honk car beep. Right? And very similarly, we define a third class, class truck, also extends from automobile. So this top one. And like sports car, it just defines its own honk method. It's just a different print statement than the other two. Okay. So the classes themselves are pretty basic, not very interesting. But if we start running the code right here, I create an automobile, I create a sports car, and I create a truck. Right? I create one of each of the classes that I had above. And then I take each object and I call honk. Notice each one of these is an automobile, right? Because truck extends automobile. So a truck is an automobile, right? It's a specific type of automobile. It's not just a general one, it's a specific one, but it's still just an automobile. So we can say automobile equals new automobile. We can say automobile, my car equals new sports car. We can say automobile, my truck equals new truck. Each one of these is still an automobile. So we can create an automobile variable to store it. And so each one of these is an automobile. Java knows, hey, this is an automobile. This is an automobile. This one is an automobile. And I call honk on each one of these. Even though we call them automobiles here, each one does a different honk. It just does something different for each of them. The first one says honk sound. The second one says honk car beep. The third one says honk truck do. Right? Different things happen. Even though each one of these is an automobile, we're calling the honk method for all three of them, but we get different behaviors. Again, this is polymorphism. You can really see that this is runtime polymorphism because if I just showed you this code, right? Like maybe this class definition, maybe someone else did it. You don't know what's there. All you have access to is this code right here. This is all you can see. Well, if you look at this code, you have no idea if the honks are going to do different things or the same thing. If you're just looking at the code, compiling the code, for example, you only figure out that they do something different when you run the program. So that's runtime polymorphism. So again, this is method overriding. You have a method in your parent class and you redefine it in your child class. Okay. So this is just something extra we did. If we didn't do this, it would have a honk method. It would just have the parent. But we say, hey, we don't want this car, we don't want the sports car to honk the same as an automobile. We want it to have a different honk. And so we redefined it. And then later on, when we use it, we see it does something different. And polymorphism, one thing that does many different things, many different forms. On the slides, I have the code as well. You do have to be a little bit careful because in the previous weeks, I gave you a car.java class, and you can't have multiple classes that have the same name. Just like how you can't have two variables with the same name, you can't have two classes with the same name. And so on the slides, it says car. I had to change it to sports car just because I already had a class car. Right. Be a little bit careful when you do these exercises. But this is the runner, which is what I had on the screen as well. So our sports car is an example of polymorphism, just like the plus sign is. The plus sign is compile time polymorphism. It's method overloading. It's one method that is defined for different inputs. whether it's different types of inputs or different numbers of inputs. You can easily imagine maybe you want to define an add function that can take in 2 things, or it can take in 3 things, or 5 things, or 50 things, right? If you define it for each of those and call it the same thing, that's method overloading. You're giving more functionality to a function. You're overloading it with functionality. You can also do overriding, where you replace the old one. So you're essentially like getting rid of the old function, you're writing a new one, and you're going to use that one instead. It's not like you have multiple options. It's like you just have a new one. That's method overriding. Any questions about polymorphism? It's definitely, I'd say everything that we've been covering in Java 2 is starting to be more advanced. It's something that I think is tricky because it's not like something you can play around with super easily. It's not like a command that you can run and try. It's just a concept. It's more abstract. You can't like touch it. It's just an idea. But that's what makes it really powerful, because it's an idea. It doesn't just apply to Java. It also applies to Python. I know some of you have done Python. It also applies to other languages, just programming in general. And so that's why it's kind of worth learning, or at least getting a start here. Questions about the slides, overloading versus overriding, and what polymorphism is, how it works. Okay. One thing I want to test a little bit, not exactly polymorphism, but I want to look at this code a little bit more carefully. Let me see if I can, make it bigger a little bit. I want to take a look at this line specifically, right? So typically how we might have wrote this line before would have looked something like truck. I'm going to make a couple of them. So T1 equals new truck, right? That's like the most basic way of creating a truck object. We say new truck on the right-hand side to create the object, to use the constructor to create an object. And then we store it into a variable. What type of variable do we store it into? Well, we store it, right? This one is a little bit different because the right-hand side is still the same. We're still creating a truck object, but now we have an automobile variable. This is still valid because a truck is an automobile. So we have a truck on the right-hand side. We have an automobile on the left-hand side. That's fine because we can put a truck into an automobile variable. It's just a specific type of automobile, but it is an automobile, right? So I want to try something else. What happens if I flip this around, for example? What if I do truck A equals new automobile, right? If we try to do it like this, we get an error. If we hover over it, it says type mismatch, cannot convert from automobile to truck, right? And so this, if we think about it, should make a little bit of sense. We can have it this way. We can have automobile truck, but we can't have truck automobile. That's because we can always convert a truck to an automobile. We can always do it because a truck is always an automobile. But an automobile is not always a truck. It's just like the square rectangle thing. Every square is a rectangle, but not all rectangles are squares, right? It's not two-way street. It's only a one-way direction. And so this also applies to programming. You can have a more general thing on the left-hand side and a more specific thing on the right, but you can't have the reverse. You can't have something specific on the left and general on the right. Right? Automobiles are more general, they're more broad. There's a lot of different types of automobiles. So it's a big category. Trucks, on the other hand, is a small category. It's just one section of the automobile category. And so you can have the specific thing on the right, but you can't have the specific thing on the left. The reason why we do it, why we care about doing things like this, can anyone think of why we might want to do this instead of something like truck? Like, why do we bother putting it into an automobile variable instead of putting it directly into a truck variable? Can anyone think of a case where this would be useful, or at least required even? As a hint, automobile, sports car, trucks, these are all different data types. But each of these variables that we store them into all have the same data type. So where have we seen a place where maybe it's a data structure that the things inside of it need to be the same class or the same type? What kind of data structure have we seen that works like that? Something that stores objects of the same type. How about Stephen? Can you think of a data type that we've worked with in Java that is a fixed size and all the elements have to be the same type inside of it? It's kind of a collection of items.
Can you say that again?
I'm looking for something in Java, a data type that is a collection of items that are all the same type and has a fixed size. So like it can be used to store 5 strings together or store 5 ints together into one thing. It's kind of like a list in Python. What did we call that in Java?
In byte?
Close. It starts with an A. If that helps. These square brackets are related to it. Do you remember working with the square brackets? If anyone else remembers, I'll also feel free to just speak up or put it into the chat. Andrew, how about you? Do you know what I'm looking for? What? Yeah, I see your message in chat. Arrays. Yep. So again, arrays are a way of storing a collection of items, but arrays, if you remember, have 2 restrictions. They have a fixed size and they have a fixed data type. So again, examples of arrays were like this. So int array ARR equals new int array of size 5, for example. And I can say like ARR 0 equals 2 or 2, ARR 1 equals 6, so on, so on, so on. And I can like system.out.println ARR, for example. So I can store things into it, I can print things out of it, And let me just get rid of this. And if I run this code, you can see it prints out 6 because I stored it there and I printed out, right? So there's 2 restrictions on the arrays: fixed size, fixed data type. The fixed size isn't really important here. What is important is that arrays have a fixed data type. Everything in the array has to have the same data type. And so if we define our variables like sports, car, my car, and truck, my truck, like if we define our objects this way, it's a perfectly fine way of doing it here. But the problem is now each of these variables are a different data type. This one's an automobile, this one's a sports car, this one's a truck. And so we can't put these into an array because they have different data types. Java is not smart, right? Even though they're all automobiles, it doesn't realize that exactly. It thinks that they're different. And so it doesn't allow you to put it into an array altogether. But when we define it all like automobile, it's kind of like tricking Java into converting all these into automobiles, which it can do because they are automobiles. And then when we convert them into automobiles, now they're all the same data type. So magically we can create an array of automobiles. We can put each of them into the array and do stuff with it. So for example, right now they're all automobiles. So let me change my code. I'm gonna create an automobile array. Automobile array equals new automobile array of size 3. And so ARR0 is going to be my auto. ARR1 is going to be my car. And ARR2 is going to be my truck. Right? I can put them in no problem. Let me get rid of this. And I'm going to change my code. I'm going to replace this with a for loop. So if this looks a little bit confusing, can try to review the slides from before. But I'm going to do something fancy. I'm going to do a for each loop. So for each automobile A in my list ARR, I'm going to do a dot hunk. Right? Because they're all automobiles, they all have a hunk method. And if I run this, now it works the same as before. Right? The code functions the same, but now I have an array. And I loop through the array instead of having 3 print statements. Just to show you, if I change this to like that, well, actually it does work, but this way you can see that each of these are automobiles, so you can put them into an automobile array and work with them like this. Okay. So again, that was polymorphism, compile time polymorphism, method overloading. That's something old that we've seen. Multiple methods with the same name, different parameter list. That's one way of getting multiple different functionalities out of like a single thing, out of a single method. Method overriding, it's a little bit different. Instead of getting like multiple options, you just have a new version instead of an old version. You get like you pave over the old version with the new one. Polymorphism. Going back to the graphic, so we covered inheritance last week. We kind of covered polymorphism just now, kind of covered it previously as well. And now I want to get to encapsulation, which I think is actually one of the easiest principles of object-oriented programming. So that's why I put it at the end of today. We can end with something a little bit more chill, I guess. So what is encapsulation? Encapsulation is the idea of restricting access to certain pieces of data and having hidden values. We've seen this with our visibility modifiers, so our public and private. But there's actually more that we'll cover today. And why do we have this? Why is it part of object-oriented programming? Well, it's a good way of like protecting our program. That's one way of thinking about it. When you make something private, it prevents like other people from directly accessing it, directly changing it, right? Because if someone has access to, for example, an integer field, like imagine you're a bank account, a bank, and you have a program that keeps track of everyone's balance, right? You don't want people's balances to be like public integers, because then anyone who has access to your program could just say, oh, hey, I want to change this number to 9999999. And then magically they have a lot of money, right? Like that shouldn't be allowed. That field, that piece of data should be hidden. It should be protected. And that's what encapsulation is all about. You're kind of hiding it from other people. You have different layers of visibility. And so previously we've seen the two extremes, public versus private. Public just says anyone can access it, anyone can modify it. Private says only I can do it, or at least only this class can do it. Okay? No other class is allowed to touch this. So those are the two extremes. Anyone can do it, only I can do it. There's two that happen to be in the middle, that happen to be a little bit like a little bit private, but also a little bit public. And I'll show examples of that really quickly. So kind of going from more private to more public, there's protected. So protected is still pretty restrictive. It's kind of like private, but all classes that inherit from this class do have access. So it's not just me, but also my children and my children's children and my children's children's children. Right? But if you're not my child or related to me, you don't have access to it. So it's like a step more public than private, but it, like I said, it's still restricted. You have to be related to have access. So for example, in my polymorphism, in my automobile, I'm gonna make a private thing. So if I make a private int x equals 7, for example. So it's a field, it's called x, and it has the number 7. In my code, well, I still need to create my objects. But in my code, if I tried to, let me fix this. If I try to do my auto.x, you'll see we have a problem. This. If we try to do this, we have a problem because it says x is not visible, right? Because it's private. However, in here we can have access. Like we can print out x here, x. We can print out x here because it's the same class, right? It's still in the automobile class, right? Perfectly allowed. What we can't do is print x in the sports car class. Even though sports car is related to automobile, it extends it. It's not automobile, right? And so since it's not the same class, it doesn't have access. It does inherit it. It's not that x does not exist. X does exist. It's inherited. It's there. You just don't have access to it. And so it says the field is not visible, right? But if we change this private to protected instead, you'll notice that here the error goes away. I do have access to x now because I'm extending automobile. I'm related, so I have access. But if we scroll down to here, the red underline went away, but I think it's because it's still the same file. Let me run it. Yeah, if I move this to a different file, then it doesn't have access anymore because it's not in the same class, or at least related class. It's somewhere else. So for example, let me try to take this and put it into some other file. Maybe let's try this. Or actually, I think I need to put it in a different package. So I'll show that later. There is default visibility. So beyond protected, there is default visibility. Another term for default visibility is package private. So it's private within the package, but if you're in the same package, you have visibility. So within the package, it's public. Outside the package, it's private. So it's kind of like, where is the boundary? Here, packages just essentially refer to folders. So if we look at Eclipse, the way things are organized here is that we have our project, which is like our main thing. And in our project, we have our source folder, which is where all of our code lies. Inside the source folder, we have different packages. Right now, I've just been using the default package, which has no name. You might be using the default package, but I know a couple of people from the screen shares, I've seen that you have your own package. You can create different packages. Right? You can say new package. I can say like first. Source folder has to be the source folder. So you can see I have a default package, I have a first package, and I can move things around. I can move, where is it? My polymorphism file to the first package. And now things get a little bit messy because it doesn't have access anymore because they're different packages. Packages are a way of separating things. So if it's public, you still have access across different packages because again, public is like the biggest, least restricting visibility. Anyone has access. Doesn't matter if it's a different package. Doesn't matter if it's a different, like 10 different folders away. As long as it's there, like as long as it exists somewhere, you have access. Package private means you have to be in the same package. Protected means you have to be related to it. And private means you have to be in the same class. But each of those are just different ways of encapsulating data. Making data in a way that only some people have access and other people don't. I'm gonna mess things around a little bit. I'm gonna move this back to the same package. And I wanna show one last thing for today before I let you all go. So here, let's make this private again. So I have this private field in my class. Sometimes what you do with private fields is you have what's called getters and setters. They do kind of what it sounds like. Getters, I'll give you access. They let you get the private variables. Setters allow you to modify them. They allow you to change private fields. And the reason they exist is they can provide like a restricted access to these private variables. I think I have some slides on them actually. Yeah, so how do we, like, we inherit these private fields. We don't have access to them immediately. How do we get them? Getters and setters. They're like an interface to these private variables. They allow you some access, but it's like controlled access. Okay? That's the important part. You can define these getters and setters however you like. You can make them restrictive. For example, maybe, I don't know why you do this, but maybe think back to the bank example and you have like classes that define people's balances, or that's a field. And maybe you want to have a setter that can say, hey, as long as you change it to something like, or maybe you have a setter that says, hey, if you want to like remove money from your bank, that's perfectly fine. You're allowed to do that. I have a setter that says you can give me a number and I'll take that amount out of your balance. Right? But I don't have a setter that allows you to add. I only have one that allows you to remove. You can do that, right? Because you write your own setters. And other than your setters, no one has access to the private fields. So they can only use what you give them to mess with the data. That's why it's like kind of the restriction is good. It prevents people from messing up your stuff. And what's really nice about Eclipse and IDEs in general, so if you're using IntelliJ, it's also there, but I'm just going to show it for Eclipse. You can automatically generate getters and setters. So if you're following along, make sure just to highlight the class, or you can highlight the whole file with Control-A. And what you want to do is you want to go to the top, you want to go to source, and kind of near the bottom, there's a generate getters and setters thing. There's actually a lot of generate commands. These are just automatic tools that create code for you. For example, toString, hash code equals, these are very common methods to override. So they have built-in like automatic things for you. There's a built-in override / implement methods. But we're gonna do the generate getters and setters. If you click on that, oops. Let's actually here. Change this a little bit. If I go there, getters and setters, I have this window. And it says, select getters and setters to create. And so if you expand it a little bit, you can choose, oh, I only want a getter, or, oh, I only want a set, or I want both, right? You can choose what you want. You can choose where to put them. So either at the end of the file, at the top of the file, after where it says X, or maybe I want it after my hunk method, right? I'm just going to leave it at last. And you can make it, oh, public, protected, or package, or private. I can make it final or synchronized. Those you don't have to worry about. And, oh, maybe I want generated comments as well. Right? These are just like all options. And so maybe I want it public, generate, and here you go. So generated comments, and you can see these are our automatic getters and setters. This getX will return our private field. Our setX will take a number and store that or update our fields to that value. And so it does it automatically for you. It's really useful if you have like 10 private fields and you don't want to write this out over and over and over again, because they're not exactly the same. So it's not repeating yourself, but it's like very tedious if you have to do this a lot of times. So that's why the built-in tool exists and it's very useful. But with these getters and setters, now the sports car can access the X value. It just doesn't do it directly. It just, you can just do get, what's it called? GetX. And so instead of accessing it directly, you access it through this getter method, right? It's like a doorkeeper. It prevents the bad guys from messing with it by restricting it to however you want to define it to be. Technically, you could define the getter to do something really dumb. Like you could just say return -1. I mean, it's a valid function. It'd just be very confusing and not very like useful. So people don't do that. I think getters usually are very simple. Like you just have access. Setters are the ones that you have to be a little bit more careful because you don't want people accidentally modifying the values when they shouldn't be. So checking the time, I'm at 9 o'clock, right on time. So for the homework this week, I didn't get as many submissions as I would have liked for last week's inheritance homework. And so I kind of want to take a break and just say, if you haven't done last week's homework, I'm giving you another chance, but please, please, please try to get it done this week. If you haven't started, it's completely fine. If you're stuck, completely fine. Just leave a comment for me and I'll message you back. I'll try to help you through it. I just want everyone to finish last week's homework because I think that's like the last important thing that we talked about. If you did complete last week's homework and would like another problem, like a challenge problem, or maybe playing around with this polymorphism, whatever, you can reach out to me and I can provide you with like a custom homework or a challenge problem. But if you don't feel like it, completely fine. It's your reward for doing the homework. I want at the end of next week, everyone to have completed the homework from class 6, which was taking the core class that I gave you and creating a new class that inherits from it and overrides a method. So we talked about overriding again this week. We talked about inheritance in the beginning. Hopefully it's a little bit more clear. If not, again, reach out, email, Google Classroom. Yeah, other than that, that's all I had. So if you don't have any questions, have a great week. I'll see you next week at 8 o'clock as well. If not, I'll be sticking around for questions. Yeah. Thank you, Devin. Thank you, Andrew. You too, Stephen. Missy, are you there? Everything ended well, so I think I'm gonna head out and we can talk later.